was written for. It's just like an exception or sending really stuff that is not supposed to be sent and see how applications or devices they behave. And fuzzing became a common practice. Again, comes down to the thing how you quantify how to test security, right? So some people say, yeah, I ran a fuzzer, or it doesn't need to be a fuzzer, I ran a vulnerability scanner or something like that against my system and everything is okay. Well, sometimes fuzzing is not done correctly, and we're going to go through how to try to make it better. And what I mentioned before, right? People, they get measured by how fast they can deliver a service or a product, and not exactly by how much security testing was done. So the better you make the security testing and the quicker and all the stuff, the better. So finally, protocol fuzzing. The best term that I like to describe protocol fuzzing as protocol abuse. You're sending stuff that you're not supposed to. When I say sending stuff that you're not supposed to, that's another good thing to remember. I'm not talking about flooding, like sending a whole bunch of packets at once. It can happen. That's the easiest way to fuzz, actually. With one Linux command, you can send a whole bunch of bad packets. But it doesn't make sense to, when I say abuse, is actually testing each one of the cases, like sending broken packets. What are broken packets? I think it's on the next slide. We're going to go through each one of those. And again, somebody says, oh, it's testing security. It's not really security. It's testing the robustness, right? To send a bad packet and the device crashes, well, that's not a good thing, but maybe it's not security, right? Could be a DOS. Again, people relate DOS to flooding, but if you take a service down, it doesn't mean if it's with one packet or several, right? Service is down. But again, you're testing how robust that target is. And, well, I just mentioned that. Could be like from crashes. And usually, what people try to use fuzzing, like security researchers and pen testers, what they try to do with fuzzing is to get some device, usually a server, in a state that the device can run some remote code execution or something like that. So that would be like the way to open the door to do some bad stuff to the system. And as I mentioned before, it's already hard to follow the specs of RFCs. Imagine if you try to do something else. It's an infinite world out there. And people really get confused with VA scanners. Oh, fuzzers and VA scanners, it's totally easy to understand how they're not the same thing. VA scanners, just like pretty much anything on the internet or about security today, it's about known vulnerabilities, stuff that people know about. So they have IDSs, they have signatures that have to match whatever virus or malware, whatever, is being sent over the network. Fuzzing is totally the unknown stuff. And people refer to fuzzing as sometimes attacks. They're not really attacks, right? They're just bad packets, but the consequence could be a bad thing. That's where the security comes into play. So what is a broken packet? Broken packet, I like to define that like 3 ways to break a packet. The structure of the packet. So the packet, like by the RFC, it says this packet has this and this and this field. You just send packets missing fields and see how that breaks. State. Some protocols are stateful. Has some sort of handshake mechanism or something like that. If you break the state, how does the device behave? You start a handshake process and you stop, or you send packets out of order, how the device treats that. And sometimes they break. They break really bad. And semantics is pretty much saying, let's say, an invalid string, that's one example, or send an overflow or an underflow. You say I have this packet containing this field, and that's how large it is, and you don't send anything there. Or it's supposed to have a number. You send a string. And again, fuzzing could be, I think that's how it was categorized in the past few, or for a long time, it's just like, this is stupid. This doesn't make any sense. And it doesn't sometimes, but it got better. So what can you fuzz? What protocols, right? We talked about applications and servers and network devices, but what protocols can you fuzz? Anything. You can fuzz from the lower level layer 2 protocols, or even drivers, to layer 2, to IP, TCP, and up to the application level. So, oh, they have a counter. That's cool. So I have half hour still. But what is easy? What type of applications people focus on fuzzing? The newer stuff, the stuff that is not mature. If you try to fuzz ICMP, hopefully devices are not going to break when you send ICMP packets. Sometimes they do, but it's really a mature protocol. But when you talk about SIP, IPv6, I've seen like cases that in IPv4, you're testing TCP or some higher level application like on IPv4, it works perfect. You put IPv6 instead, it totally breaks, just because it's not that mature yet, like in the market forever. SCADA systems. I'm going to get into critical infrastructure in a little bit. Who saw the talk yesterday about SCADA? So that's something, so SCADA systems, they're fairly newly connected to the internet, right? They used to be separate systems, now they're somehow connected to the internet. So it's not that people did that on purpose. They didn't write bad protocols or stuff like that, but they just didn't think, right? And when you talk about critical infrastructure, breaking that and causing a DOS could be really bad. And I have some crazy thoughts about critical systems, so I'm going to get to that towards the end. Wireless, last year at Black Hat was the Apple thing. People freaked out, right? You didn't even need to be connected to an access point to be exploitable. It's just have your card on, and that would be exploitable. That's really bad. Bluetooth. Who saw the last talk here? So how was that? I didn't see that. I was getting ready for this one. But I guess like some people, there are fuzzers specific for Bluetooth. So it's something really cool to look for. And video games. You can fuzz, again, everything. Like there are PS3s, there are Wii's, there are, what else? Xboxes, they connect to the internet as well, right? What can you do with that? And then you go back to one of the keynotes yesterday, right? People, like, the real life and the online life, they're all merging together. And goes back to the thing that I'm going to talk about, critical systems anyways. So let's get to the point that things get probably a little interesting. Nonsense, so let's talk about protocol fuzzing, finally. Nonsense fuzzing. What is nonsense fuzzing for me? Is you have one network device, you have IP connectivity with that device, and you just send bad packets. How do you send bad packets? How do you generate bad packets? I don't know, there's actually a really good book about fuzzing written from the Drum, Amini, and two other guys. And he has a great example there. You just cat /dab/u random, and you point that to a netcat to any port, or to a NIC card, and just send random stuff on the NIC card. I have some packet captures that I'm going to show you guys later. And you can see that sometimes the packets make no sense. Sometimes they think it's something like some valid packet trying to do, for example, a DNS zone transfer or something like that. And I was just sending random packets. So that's kind of scary how things could break so easy. But again, the point here of nonsense fuzzing is just throw bad packets. It's the worst, is the easiest, dumbest way to do fuzzing, but you can break stuff. The problem with that, and that's one of the challenges, I have a challenges slide, it's not monitoring. Monitoring is one of the challenges, but reproducibility. If I leave my laptop running with this kind of totally random stuff, I come back, I break something, like, excellent, I broke it. How do I reproduce that? What actually packet caused the problem to break? If I'm not sniffing, even if you're sniffing, right, you're sending a whole bunch of packets. How do you determine what's the fault, do the fault isolation? What's the packet that actually caused the problem? Reproducibility is really important in fuzzing. Then going a level up, right, you have session-based fuzzing. What is session-based fuzzing? Let's say you want to test the FTP protocol in some device, in some server. You want to break FTP. That means that whatever underlying parts, like IP and TCP, you're not going to try to break that part of the packet, right? Because, of course, if you break IP, everything else is going to break. But again, you're breaking IP, you're not breaking FTP. So this is what mostly is being done lately with fuzzing, is do a session-based fuzzing. You want to test a certain protocol, you send things on that level. Finally, how things are actually happening right now, it's stateful-based fuzzing. It's pretty much like the one before. The difference is that you're interacting, or the fuzzer is actually interacting with the device. So you're not only sending valid packets or every once in a while to test HTTP GETs and stuff. You're actually following what the protocol says, following a conversation, following a stream to try to break stuff. We're going to see some cool stuff on the challenges too. But, and it's possibly a better way to, not only to fault isolation, and this is actually not correct what I put here, but it's a good way to find what things, to try to determine a problem and to get to the bottom of a problem. Just throwing back, even if it's up there on the application level, if you want to send stuff, or application level. To send that on the application level, you might break it, but again, it could be hidden. You might not get all the corner cases because you're not going to hit that part of the code. That's the important part. So what techniques people use to do fuzzing? And this is, again, this is fuzzing in general, actually. Totally generate packets at random or pseudo-random techniques. So you're generating packets, and hopefully you're able to go back and see what, if you have to replay that or reproduce that, you're going to do that. Or you have some sort of database, like how do I break TCP? And you have a database, and you're going to run exactly the same test cases against something. Which one is better? Really hard to tell, right? Because if you think random, like the random one, you could run this test forever. Random is random and infinite. So what can you do? Like, it's going to run forever. You might find tons of bugs, but when to stop. That's the whole thing about fuzzing, when to stop. Then you got the other one. The other one has a certain number of test cases. You run that, and it ends, and that's it. How sure goes back to that thing? How can you quantify how much was tested? You can run for several days. You can run for a week. Sometimes it's not going to be enough. I like to think that a mix of both would be a good thing. Leave, like, for the people to choose what to do, how random they want to get. So, and what type of, you put limitations. I'm not sure if there's a tool that you can do that today. So that's something that, for me, almost last slide, one of the things that hopefully I'm going to have time to try to work on soon. So the challenges, these are just some of the challenges, but probably the main ones. Number one is fault isolation, as I mentioned. If you cannot reproduce a problem, even if you broke something, wow, I broke it, really cool. How do I do that again? Good luck if it's totally random. One that is really, really, really hard is the bug behind the bug, right? Let's say you sent a packet, it broke something, and you're only going to find, like, how can you test if there's something broken behind that thing? So somebody has to fix the problem, then you run the same test to hopefully hit that problem. So it's totally, the goal of fuzzing is to do like a code coverage, right? Try to exercise all the cases that you're supposed to handle. Slow protocol implementations. That's something that it really sucks when you're trying to do some tests. You're trying to run something against a box, and the box either, like, let's say it's a firewall or some sort of box that says, well, I don't accept any packets from you anymore. That's one problem. The other problem would be really slow implementations. So you're trying to send, if you're sending some sort of instrumentation, some valid packets, one device answers, like, the timeout is higher than the other one. So your test that was supposed to run in an hour could take a few days. It happened to me testing some device that I had like 5 protocols. It ran in one day. I added SSH to the thing, and then it became like a 6-day test. That kind of sucks, right? And it goes like from implementation to implementation. If you get SIP, for example, SIP there's so many cases, and it's a protocol that there's so many applications. There's not only like commercial applications, there are other applications as well. And each one does like things differently. although